Hi folks, welcome to another episode of NYC CNC. Today we're going to start a two-part series on using servo motors with Arduinos. I covered this topic about 3 years ago. A lot has changed in the Arduino world. I've had a lot of questions too on some basic introductions to servos, so this first video is going to be a very basic introductory to how to get servos working. First, let's take a look at the parts we're using today. Two of my favorite companies for ordering Arduino and electronics parts are Adafruit and SparkFun. I am actually using a slightly older version of the Arduino that's shown here. This is the current Uno version, and in fact they have a newer one called Leonardo, but we won't get into that today. Any of these Arduinos should work fine. This one is about $30. The new Leonardo one, which has more features, is actually even cheaper. We're using a standard hobby servo. Mine is slightly different than this one, but for all intents and purposes, same thing. These can be had from anywhere from $5 to $20, and this one here is $12. I'm also wanted to point out that I'm using some of the Adafruit breadboard wires that are very helpful. They have different packs based on male and female and such, but would highly recommend those if you're a breadboard user. And finally, the second part of this tutorial, I'm going to be using a FlexiForce pressure sensor, which I purchased from SparkFun. We're going to go over two different tutorials today. The first one is the sweep tutorial. Anyone who downloads the Arduino software can get that by going to Examples, Servo, Sweep. We're not going to change the code, but I do want to quickly walk through it. It includes the servo.h, which is a sort of a pre-programmed servo library that saves a lot of time and is one of the main features to the Arduino hardware and software platform. We're adding a servo, which we're calling my servo. It could be servo 1, whatever you want to call it. And we're creating an integer POS short for position, and we're storing that initial variable as 0. You don't actually need to store an initial variable, but that's fine. In the void setup, we're doing my servo.attach 9. So we're attaching the servo to pin 9. I'll show you what that means when we take a look at the hardware. And then in the standard Arduino code, which is a void loop, you say for position 0 to position 180, or actually 179, position equals position plus 1. What that means is it's looping through such that position equals 1, then 2, then 3, and every time it's writing the servo to that position. So what it's literally doing is every 15 milliseconds, which is what the delay 15 means, there are 1,000 milliseconds in a second, it's writing the position of 1, 2, 3, etc. If you're asking why it's 0 to 180, or actually 0 to 179, it's because the standard hobby servo only rotates between 0 and 180 degrees. It doesn't make full, complete, continuous rotations, but it rather does sort of half circles. So then the next one, it's the same code except you're descending from 179 back to 0. So let's take a look at the Arduino and hardware, and then we'll run this code. So as I mentioned, I like using the jumper cables from Adafruit, and here I'm using them to connect the servo wire, which you can see here. This loops back to the servo that's held in the vise just for stability, to either the breadboard or directly onto the Arduino. The standard hobby servo has 3 cables, a black, a red, and a yellow. The black, and this is, I'm sure there are some rare exceptions, the black can go to ground, the red can go to the voltage positive, which in this case and for most hobby servos is 5 volts, and the yellow goes to the signal, the sort of signal pin on the microcontroller telling it what to do. So I've set up this breadboard with the yellow cable, jumper cable going from 5 volts over here to this 5 volt rail on the breadboard, and the orange cable from ground to the ground rail. That lets me use these rails that run along the breadboard for my positive and negative connections. And as you can see, I've used a red jumper cable to hook up the positive voltage and a black one to hook up the servo motor's negative voltage. And if you can see this yellow wire, it snakes through here and goes to pin 9 on the digital output pin of the Arduino, and that references the myservo.attach 9 code we just looked at. For now, you can ignore the other connections I've got right here. We'll talk about those in a second. So let's hop back over to the software, upload the code, and see what happens. Again, this was a sample code, so no changes needed. We'll just go ahead and click upload. and you'll see right here the status. It'll say done uploading in just a second. Done uploading. So let's take a look at what happened. So simple enough. You can see the servo is rotating from 0, which I would say is on the left, all the way up to 180 degrees, and then back to 0. So now let's take this up a notch by interacting the servo motion with a sensor. So go ahead and go to File, Examples, Servo, Knob, and that opens the code here. I've made a few edits that I'll go over. You'll notice much of it's the same. The first new thing we have is this int pot pin equals 0. This example actually is intended for a potentiometer. We're going to use a different type of sensor. It looks very different, but it works the same way. It's a resistive type of sensor, a variable resistor. The first piece of code I added is serial.begin 9600. That's going to let us use a serial monitor screen on the computer to watch what's going on with the input sensor. And then what we're going to do is we're going to say val equals analog read dot pot pin. So that pot pin is the input pin of our sensor, and it's going to do an analog read. It's a good time to mention the difference between analog and digital. There's a great example, which is analog means how much does something weigh. If there's a scale of possibilities or range of possibilities. Digital just means yes or no. So in other words, is the cat on the couch? That's a yes or no question. That's digital. How much does the cat weigh? That's an analog question. A pressure sensor can obviously have a varying range of pressures too. That's an analog type sensor. We're going to code out this val map command just for now. I'll show you more about that in a second. And then what this is doing is it's writing the servo position to the val, and then this serial.print line prints the value on that serial monitor. So let's talk about this FlexiForce pressure sensor you can see here. There are 3 leads coming off of it. The middle lead is actually a dummy lead. The lead on the left here uses a red jumper to connect directly to positive 5 volts, and the lead on the right connects to 2 different things. It connects to a resistor that pulls it down to ground. You can research pull down resistor if you'd like to learn more about that. And then it uses this green cable to go all the way over to the analog in port 0, which we referenced on the code earlier when we said int pot pin equals 0. That meant an analog input on pin 0. So what's going to happen is I'm going to squeeze this sensor, and it's going to give me a value, and that range will be between 0 and 1023. That has to do with the way that binary numbers work. So it's a range of 0 all the way through 1023. An important thing when you're taking new steps in Arduino code is to take it step at a time. So what we're going to do is we're going to just focus on the pressure sensor and not worry about the servo yet, and we're going to use the serial monitor to monitor what the input is for that pressure pad. So I've got it hooked up okay. You'll notice I've actually disconnected my servo right now to take it out of the picture. We're going to hop back over to the code, and what we're going to do is I'm going to squeeze this pad with my finger, and we're going to see what happens in the serial monitor. I forgot to mention one other change. I increased the delay to 100 milliseconds. That's 1/10 of a second, just to slow down the pace at which it reads the code. You'll see why in a second. We're going to go ahead, first of all, upload your code, and then we're going to go to Tools, Serial Monitor, and you're going to see these numbers indexed down. If I had left that delay unchanged, I think at 15 milliseconds, these numbers would be refreshing far faster than need be. So you can see these numbers are in the, let's call it 20-ish range. I'm going to go ahead and I'm going to pinch the sensor, and we're going to see them jump up all the way to 500 and 600 even if I squeeze really hard. So what we want to do is take that input range of 0 all the way up to 1023 and make it correspond to what the servo can actually move, which is only between the numbers 0 and 179. And that's what this map function does. It says take the distance of the range of 0 to 1023 and sort of downscale it so that actually only means 0 to 179. So what we'll do is we'll go ahead and upload this code, and then we'll pinch the servo, and as we pinch, we'll pinch the sensor, and as we pinch it, we should get the servo to indicate and move over to that position that correlates to how hard we are squeezing. And there we have it. If I squeeze a little bit, the servo just moves a few degrees, and if I squeeze as hard as I can, it moves over. If you remember, the furthest I got it in the serial monitor was about 600, and that explains why it's not rotating all the way over to the right, because if you think about it, 600 is only a little more than halfway to the range of 1023. So when it ports that or maps that down to the degrees of the servo motion, you'll see that's why I'm only getting over so far. That wraps up today's tutorial. Stay tuned, we'll have the second episode of this two-part series where we'll cover using larger servos as well as some more tips and tricks. Thanks, folks.